Hello everyone, I'm Sneha. In this video, I'm going to talk about cost function and gradient descent for regression.
Before going to the main topic, let's understand hypothesis function. It is a polynomial function used to predict the output. This is the training data, that is, machine is given with both input and output to train and to use it for prediction in future. The hypothesis function is just a relation between input and output, like y is equal to a into b plus c or a into b minus c and whatever. We have to generate a general form to get a better prediction. For example, let's take a linear function for the price prediction using the training data available. Consider some random values for theta 1 and theta 0. And if we substitute x value as the first value in table, we got h is equal to 1052, but the actual output is 460. It doesn't even close enough. Likewise, if we calculate for other input values, we get this. But actually, we have to get this. There is a difference in actual and predicted output. This is the combined graph of previous two graphs. Our goal, or any person who works on ML algorithm goal, will always be to reduce this difference and make it minimum. So before even minimizing, we should know the difference value. This difference is estimated using cost function. Since I am using very small training data, we can manage having 4 different values. But in reality, we will be having thousands and lakhs of training data, and we cannot handle difference for each data. So to get an average of all these difference, we will use this formula, cost function formula, and will get only one number. For the above example, that equation considered, we got 1.685 into 10 power 5 cost function. Cost function is nothing but a difference. In order to reduce this, we have two methods. One is updating manually, second one is gradient descent. In updating manually, observe this equation. We cannot change x values, but we can always change parameters in order to get optimum prediction. So let's now consider theta 1 is equal to 0.2, theta 0 is equal to 0. Now we can say we have less cost function. Likewise, we have to try other values until we reach this minimum. But this method becomes very difficult for large data set. To overcome this difficulty, we use gradient descent. It's an algorithm used to update parameters, and formula is given by this. Here you need to take care of alpha and number of iterations. If you take alpha too small, it takes long time to reach minimum cost function. If you take alpha too large, it overshoots and may never reach the minimum. And number of iteration. You have to specify number of iterations within which the theta need to be updated. Now let's understand the code. First, I have initialized training data. You can also import table if you stored training data in table. Then I have asked user to enter theta value. If you want more than one theta value, then you can give vector as input. Create a hypothesis function using input values of training data and theta values. Now we have to calculate cost function. So I have calculated mean separately to avoid complications. Then used that calculated value to calculate cost function, as you see. Then our task is to find gradient descent. So in order to calculate gradient descent, we need alpha and number of iteration values. After receiving those values, I have used for loop to update parameter. And every time when you update parameter, you have to calculate its hypothesis function, since you are updating it to use in the hypothesis function which best fit. Then plot x versus y and x versus h to cross verify. If you want, you can also check theta value. Before executing the code, if you have not subscribed to our channel, please do it and support us. As from our channel statistics, we found that only 5.1% of viewers are subscribing. Now let's run this code. Let's give theta value as 1 and see how much the cost function value is. So it's quite large. And you can see the difference. The cost function, this distance are large. So let's try with decreased theta value and see what would be the cost function then. Let's give 0.5. Yeah, it's quite reduced. And let's see the graph how the hypothesis function is close to the actual value. See, it has, I think the distance is reduced when we give 0.5 than when that was in 1. So let's further decrease this theta and see what would be the cost function value. Yes, it's still decreased. And you can see which has the closest hypothesis function and the reduced cost function too. So likewise you can estimate what is the cost function, and according to that you can increase the theta value or decrease the theta value accordingly. And if you want to update parameters, you can also go for gradient descent algorithm that I have also mentioned in the code. You can also try it. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future. MATLAB is our feature. Happy MATLABing!